Welcome back. Now we're going to see a bunch of small examples just to check that you've understood the technicalities of how to handle functions in Java, and then we're going to see a slightly bigger example. So here's the first example. You're going to choose the correct instructions from a multiple choice thing to be placed in the body of a function such that the function will return the cube of a number. So there's the skeleton. We've got the header of the function, public static int cube int x. So the function cube is supposed to take an integer variable x, and it's supposed to return something of type int, which will be the cube of its parameter. Here we've got 4 options, and what I want you to do, I want you to pause the video and think about it for a moment, is to say for each one, will this work? If so, why? If not, why not? There might be more than one option that works. Are you back? The answer is that 3 and 4 will work and 1 and 2 will not. Well, let's have a look at them, starting from the correct ones. 3, we've just got a single line. We are returning the expression given by taking our parameter and cubing it, and that will work just fine. 4 is equivalent to it. We are using the parameter, the int x, which is a parameter to the function, just as though it were an ordinary variable within the function body, and we can do that, so we can assign it a new value. And so the right hand side is evaluated using the old value and gives us a cube of the parameter, and then we say let that be the new value of the parameter x and then return it. I think that's rather bad style because it kind of confuses the integer with the cube of the same integer, but nevertheless semantically it works. Line 1 will not work. Why not? Because that version of the function has no return line, and it must. That won't compile because it'll say this function is supposed to return an int and doesn't have a return line. Number 2 is slightly more interesting. This one will not work because you are redeclaring an int x when there's already an int x. There's already an int x given by the parameter to that function, and you will find that the Java compiler, it doesn't allow you to shadow or anything like that. It just says you can't do it. X is already defined. So have a go with those and internalize what they carry. Next question. What does this print? Pause the video. Have a think. Are you back? That's what it prints. Why? Because this is a classic example of where call by value means that the shenanigans that go on inside the swap function actually do not affect the original values of the similarly named variables a and b in the calling function. So we start off with a being 2 and b being 5, and we print that out in the top line. And then we call the swap function, and within the swap function the 2 are swapped and printed out the other way round. But once the swap function returns, there is no effect on the values of a and b in the calling function, and so we have the original order. Next question. What does this print? Again, pause the video, really do this, please really do this. Work out what you think it's going to print, and only then go on. It prints this. Now, make sure that you understand in detail what's going on here. I'm not going to talk through it this time line by line because it's a classic example of what we already talked through earlier on, but the idea is that because we're passing an array, it is possible for the function acting on the array to modify the elements of the array, and in this case it does so. Right, now let's look at a slightly bigger example. Whereas in the pocket money example at the start of the lecture, we started off with an existing body of code and then we improved it by refactoring. We replaced duplication of code by calls to newly extracted functions. This time we're going to start with a problem and write and show how to solve a problem using functions from the get-go. But initially we're going to show why you might want to do it that way. So here's the problem. suppose that what we want to do is to say we want to give a sequence of xy point coordinates as the arguments to our program, and we want to have one of them identified as the red point, which we're going to call the centre, the special point of interest. And what we want to do then is to look at all the others, and we want to have our program calculate which of the other points is closest in Euclidean distance to our red point. Here's the solution. I'm not expecting you to read that, because the point is you really don't want to put yourself in a situation where you expect to be given such a problem and immediately sit down and type a screed of Java code like that. If you expect yourself to be able to do that, you will get it wrong. And even if you don't get it wrong, if you come back 6 months later and try to modify it, you won't be able to. So you need better structured code than that. Let's see how we get to better structured code. It will be much easier if we break thus down into functions. Well, let's think in step by step about what we're actually going to need to do. This is called top-down decomposition. We're going to need to parse the arguments to our program. We said that was going to be given as a sequence of x and y coordinates, so of course they're going to be strings on the command line, and they're going to have to be turned into something actually representing points. Then we're going to have to get the centre, and it's just by convention that's going to be the first point. The first point is going to be treated as the centre. We're going to print it. Some of these decisions are kind of arbitrary. We're deciding what we're going to do at this point. Then we're going to get all the neighbours, so we're going to build points from all the other arguments. Then we're going to calculate the distances from each neighbour to the centre point. We're going to print them out. We're going to calculate which one is least, and we're going to print out that one. Okay, so this is at least, it's a handle on the problem. We can see what we have to do and in what order. The next thing to do is to think a bit more about how we're going to do each of these steps. So, in order to parse the arguments, what is the input and what is the output? So, we're reading from right to left. So, the input is the arguments, that's the string arguments that appear on the command line to our program. Parse arguments is the process we do, and the result is some representation of the points that are of interest. Okay? So similarly, how do we get centre? What's the input, what's the output? Well, the input is the points that we calculated in the previous step. The process is get the centre, and the result is whichever point it is that's the centre. Printing the centre just requires the centre itself as input and doesn't have any output, because the output is going to be a side effect that's going to be the side effect of printing on the screen. To get neighbours, we're going to have to look at the points again, carry out the get neighbours process, whatever we decide that's going to be in our code, and the output will be a collection, probably an array, of neighbours. To calculate the distances, we're going to need both the centre and the neighbours so that we can compare them in the appropriate Euclidean sense, and the result will be a collection of distances. And we can print them out. Then we're going to have to look at those distances and work out which one is least, and then we're going to have to print it. Okay, this is progress. Let's have a look at the steps. So, this is a representation of the high-level process that we just designed. Okay, so we're saying what's our main function going to do? It's going to parse the arguments, getting some points, it's going to get the centre from the points, it's going to print the centre, and so on and so on. Do you see? All we've done is we've taken those steps that we expressed in English and we've expressed them in Java. Okay, so we've added some types and we've stuck brackets in appropriately. Now there's only one tiny problem. None of these functions that we're calling actually exist yet. So the next thing we have to do is write them. Okay. Well, let's think a little bit more about what it is that we have to write. So down the bottom we've just got a copy of the main function that you saw before, and at the top we've got the header lines for all of those functions that our main function makes clear that we need. And we've got our bodies enclosed in curly brackets, but we've only got ... dots for the bodies so far. So our next task is going to be, for each of these functions in turn, actually write the function. And surprisingly enough, you now know enough Java that you can do all of this, but I'm going to go through it on the slides. If you would like, would like a challenge, this would be a great point to just say pause the video, look at this slide, just have a go at writing all of those functions for yourself. Because in principle you can do it, and if you can do that, do it. That'll give you a real sense of achievement, and anything you have trouble with, you can just come back to the video and watch it. So here's the parse arguments function. Now, what is there to say about this? Not really a whole lot. One thing you might wonder about is how much error handling do you want to do, and that's always a question. And in this particular version of the parse arguments function, we're doing a tiny bit of error handling. We are not handling really in any sensible way the cases where the user doesn't give us decent arguments, but we are just doing one thing. We're saying, the arguments are supposed to be xy coordinates which are going to occur in pairs. What do we do if the user gives us an odd number of arguments? And the decision that the writer of this code has made is that they're just going to ignore the final argument if there's an odd number of arguments. So it's a slightly idiosyncratic way of doing it, perhaps. We're saying if n is odd, that's what the if n%2 not equal to 0 does, then decrement n. So you've seen the n++ operator. I'm not sure whether you've come across the n-, operator, but you can guess what it does. It replaces n by 1 less than the previous value of n. In other words, we start off by setting n to be the actual length of the args array, but if the length of the args array is odd, we're going to do nothing more nor less than simply ignore the final argument and pretend it wasn't even there, and proceed with n 1 less than it was before. Okay. And yeah, what else is there to say? We're going to create a new array of doubles, call it p, and then we're going to iterate over the length of p, and we're going to fill in each element of this array of doubles by looking at the corresponding argument and calling the parse double function, which we conveniently find in the double class, in order to get a double out of the appropriate string. And having done that, we're going to return that array of doubles, and then we're done. Okay. Now we've got the getCenter function and the printCenter function. These are both reasonably easy. What are we doing? We're going to say that the first point is our center. In other words, we're just going to take in the array of all the points, and we're only going to look at the 0th and 1st indexes into that array, and we're going to take those two as being the array of coordinates for our new center point. And so our center point is going to be represented as an array of doubles. It's going to be an array of length 2. Okay, and you might very reasonably ask, isn't there a better way in Java of representing points? And the answer is yes, we could have a point class, but you don't know how to write classes yet, so just hold on for a moment. For a moment, our points are going to be represented as arrays that happen to have length 2. Okay. Now, what about the printCenter function? Yes. So we're going to print out this array of length 2. Notice that the code assumes that it has length 2, and that's possibly your first use of the printf function, which uses some rather curious formatting commands there, which you may need to look up. I don't have any slides on them right here, but that's worth understanding. Okay. Now, what about the neighbours? We are now going to be looking at the points again. Now, we're not going to look at the first two elements of that points array, because those were the coordinates of the centre, and we've already dealt with that. So that's what the 2 stuff is dealing with there. You may have to look at this a bit slowly and convince yourself that it's doing the right thing. But what we are doing is we are going to get that new array of all the other points. Now we're going to do the distance calculation. Well, you actually already saw the distance function earlier on in this lecture, so there it is again. And we're going to use it this time within the calc distances function, because the calc distances function is going to take the centre and the neighbours, and it's going to look at the neighbours one at a time, and in each case it's going to get the appropriate coordinates, and it's going to call the distance function on the appropriate 4 coordinates, the first 2 representing the centre, the second 2 representing the coordinates of the neighbour that we're looking at right now. What else is there to say about this? And we are conveniently handling, using the divide by 2 lines there, the fact that there are going to be half as many distances as there are points excluding the centre. So you may need to think about that for a moment, but it's just making sure that we fill in the dists array at the appropriate indexes. The thing you need to convince yourself looking at this code is that that I in the line dists I divided by 2 is always actually going to be an even number, so that the index into the dists array is always going to be an integer. Some comments wouldn't have gone amiss, but then they probably wouldn't fit on the slide, so there you go. And we have the print distances function, which is going to use a for loop. Ooh, there's a missing curly bracket there, isn't there, actually? There's a typo. Yes. Sorry about that. But that's otherwise unobjectionable, I think. Another instance of printf. So again, if you haven't already looked up the printf syntax and how that funny format syntax works, now's a good time to do it. Then we have to calculate the minimum distance. There's a little exercise for the reader, which is to say that top function, calc minimum, uses a 3-part for loop. But actually, this is a classic case where it would be better to use a for each loop. Can you manage to rewrite that using a for each loop? Printing it out is just another printf statement, and there we go. So, here's just the same slide again that we had before, but now you have hopefully seen it done. Okay, so you've seen us decompose a complex task into simpler steps. We didn't this time directly use the fact that we were hiding implementation details from the callers of a function, but you saw it being useful when you saw that we could read the main function and understand what it was doing without looking at the details of what each of the functions was doing. You could understand the high-level strategy that we were using to calculate that minimum distance and print it out. Right. Okay. So, in summary, Java functions, they take 0 or more input arguments. I'm not sure we actually saw any cases where it took 0, actually, but experiment with that. If it doesn't need, yes, I suppose because it's not very useful for static methods, that's why we've not seen 0 yet. You'll see 0 argument functions more often when we see instance methods later on. Returns at most 1 output value and can have side effects, for example, sending output to the terminal. And we saw a bunch of stuff about how structuring your code using methods has a whole bunch of benefits, which I won't go through again because I laboured that quite a lot before earlier. People always ask at this point, what about recursive functions? In Haskell, if you did Inf1A last semester, you spent a long time writing recursive functions, and you might think, well, why haven't we seen any recursive functions in Java yet? You can write recursive functions in Java. There's nothing that stops you doing so. It is not typically how things are done in Java. So there are cases where it's very useful, so you should remember that you can do it, and there's an example of factorial in one of the lab sheets. But generally speaking, we're more likely to use iterators over collections, which you've not seen much of yet, but you will later. And we've seen the concept of refactoring, improving the structure of code without changing the functionality. And that is the reading. And I'll stop there.